Good morning, everyone. Do I have an exciting day planned? The answer is yes. Yes, I do. So, I suffer from the million task syndrome. I just made that up, but it totally works. Where the to-do list just keeps getting bigger and bigger. I could literally write down 100 things I want to do right now in like a few minutes. Like, there's just always stuff that I want to do. And new stuff is more exciting than old stuff. So I keep coming up with new ideas, and I never finish anything until I do, and it's amazing. So last night, I committed to a plan that I've been kind of toying with for a long time, but the night before, write down 5 critical tasks that you're gonna do the next day, write them down. I've got my little field notes in my back pocket, so I wrote down my 5 tasks. And my job today is to do those 5 tasks and nothing else. When they're done, I can do whatever I want. They're done. And they're all centered around making the blade and the fixture and the tombstone and things like that. So they're just, I'll read them to you right now. Face the tombstone, like I've been talking about for a long time now. So I got to deck the 4 sides. I'm going to deck one side and then probe it and just see how like close my dimensions are to where I think they're supposed to be. That way I don't make 4 bad sides. I can like walk in the first side. I'm going to mill the soft features in the tombstone for the soft blade, like where the blade's going to mount to and everything. So I got to do that. I got to finalize the detent ramp and the hole in the blade for the detent ramp. I'll get to that later. It's a nice redesign of the detent ramp versus what the Norseman's been doing. I got to finish the tool paths, making the soft blade itself. I got a couple more to add on there, and then I got to make a blade. Those are my 5 tasks. I'm doing them. Let's go. Let's go. Yeah, that was better. Rask. Okay, we're taking a soft blade, not heat treated, just water jet, a little bit of surface grinding on it already, and then we're putting these features in it today, which includes a profile, nice profile all the way up to there. And the corner rounded, flipper tab and a lot of tight details in the detent hole and the jimping and the pivot's got to be perfect, etc., etc. So there's a lot of critical. I mean, this makes the knife right here. It's got to be good. That's what we're doing. So I like that I'm taking a different course of action today, focusing on Kern first thing. Got my 5 critical tasks. Gonna bang them out first thing because I'm getting really sick of not turning this machine on until 4 o'clock in the afternoon, and then really having no time to play on it. I want this to be priority today. I almost did it. I started getting super distracted with emails and other stuff and work and walking around the shop looking at inventory and stuff, and I was like, no, I gotta focus. I got stuff to do. I got a list to crush. Okay, so real quick, we got, like I said, I've got it separated into one file, like one side. So the facing and the little corner rounding, and then I moved it into complete, and I have simulated the completedness. And complete says, let's see, it says 4 warnings, optional stop, optional stop, optional stop. Not a big deal at all. There's no warnings at all. That's good. So complete says we're good to go. So I can post this code, throw it to the machine, and let's go. So before I got too deep into it, I wanted to get a little distracted and confirm something. So last week we faced the top of the pallet when it was vertical. So we faced the top of it, and I left 40 thousandths of an inch because I wanted to see how good of a finish I got, and I wanted to see how accurate it is in thickness. So I never did measure the finished dimensions, but what I did just now is I put the probe in, I rotated, because the probe, when the thing is vertical, the probe can't reach the top. So I touched the side here, and I stored that value, and then I went over here and I touched the side there, and I stored that value, and then the math tells me easily what the distance is there. Now I'm getting 7.5404 and a half, so it looks like we're 4.5 tenths thicker than we're supposed to be, which is completely fine for right now. But that might tell me that the tool is cutting 4 tenths thicker. So if I went through and I cut every side, faced every side, each side might be 4 tenths thicker than it should be. And as I'm maybe this is pointless, but it's a good exercise for me to go through to know what my tools are doing, know what the machine can do, etc., etc. I was mistaken. The first thing I have to do is I have to face the top of the pallet, get that 40 thou down. I was going to start doing the side, and I was like, duh, got to do the top first. So I've got facing up and then a contour up around the outside that's going to put that corner radius on. Let's do that. This is looking good. Okay, I didn't go crazy with the step over, like it's lined on purpose. Of course I could go like super micro fine step over, but even this cycle took 9 minutes just to do that radius. So there's no point. But it's pretty shiny. Yeah, that's all right. So right now I've got it mounted at 45 degrees and I'm doing that edge again. So it's just going up and around. And then as I'm watching it, I'm realizing that on the upstroke, it's nicely cutting, but as it's plunging down the other side, it's starting with the tip of the end mill and it's plunging at an angle down, so the tip is doing a lot of work, and the tip on a ball mill isn't usually that happy to plunge or to do much. So I realized this is not maybe the most optimal tool path, so I'm curious looking at it once it's done here any second now, if I'm going to see a visual difference between the upside and the downside of each cut. Almost done. All right. How's that for a reflection? It's a little wavy between each step. That's interesting, but it's shiny. Okay, let's check this out. They look pretty good. So this face is finished, this one's not finished yet, there's still some stock. That's why you see a bit of a bump there. So I'm gonna come in next and face this side after I confirm how thick this side is. These look cool. I thought this would be kind of a good idea, so that as we lift the pallets later on, take them out of the racks. We got to lift them, we got to put them on a bench, we got to load them. I thought these would be helpful to add grip, and I think I'm right. I think they are. And they're not so sharp they're going to cut you or anything, but it's cool. Plus it looks awesome. So yeah, my suspicions are totally confirmed. As the tool's cutting from this orientation, from left to center, it looks amazing. And then as it goes down this side, it starts to get really gross. I don't know if we can see that. It's just like fuzzy. I don't know, all this shiny section you see right there, it's hard to see through the shine. Doesn't look that good. So with 5-axis, you can tilt the workpiece a different orientation. I was thinking what would be really sweet also is to have the tool basically stays still and the workpiece rotate around it so that the tool always gets the same attack angle on the part. That might work as well. I don't know, a bunch of different ways to do it. I'm still learning. Having fun though. This is looking good. So now I'm going to probe this side. I'm going to lay it flat, probe it, see how close to perfect I got it. Alright, so I have the workpiece down, I'm probing the top surface, and the numbers are not making sense. And I've been crunching about it for a little while, trying to understand why, and I think I finally got it. The way the 5-axis works with, what's it called, planar spatial movement or something, everything's actually based when it's normally up and down. That's your X0, Y0, Z0. When you tilt it, you have to use a, let me get out of this. You have to use a plane spatial code that tilts everything. That's the cancel code that I just showed you. So I think I have to run the tilt first for the X and Y to actually make sense. Because I'm touching the surface and I think Z0 is not center line until I run that code. So I'm going to try that and have it make sense. Because they're close, but they're like 20 or 30 thou off and something's just weird. Alright, this helps make a little bit more sense of it. This is the code that I just ran to do the facing and that ball mill stuff. And the code itself from Complete has plane spatial A-axis, B-axis, C-axis. So B -90, which makes sense, because this is -90 when it's laid down like that. C 135, which is the rotation I need in order to get the face that I'm looking for. And I forget what M140 means, but I think I need to run this, and then I can probe, and then the probing will make a little bit more sense. Okay, I think I'm onto something. In my MDI screen, which is super awesome because it remembers all my lines. This is like my quick and dirty, you know, call tool 0, 190, touch probe, all little things I need to type in every now and then. This remembers it, which is sweet. So I did just like before. It's plane spatial B -90, C -135, and then a reset on the next line. So it's pretty cool when I run that. It automatically moves the probe out of the way, does my rotation, and then if I run it again, the reset line, it resets it back to 0. So let's run it again and let's see what the touch probe says on that face. So I'm getting the same reading as I was before, so that plane spatial didn't fix what I thought it would. I'm getting a reading of 1.93 inches. I think I should be getting 1.975. So something's like 50 thousandths off, or 40 thousandths or something. I'm not sure yet. I'm not saying it's wrong, it just doesn't make sense yet. Because I measured it with, you know, real life stuff with calipers, and it seems accurate. I don't know yet. Working on it. I think I got it. Maybe. Okay, so I'll show you what I did. I went to the touch probe screen, did a single point touch, Z negative, cycle start, probe goes down, boink. Gives me a value of 1.931, measured value. That doesn't make sense. I think it should be 1.975. So I did the next step and I wrote the number, the measured value into the table. This is the preset table. And I go entry and preset table to value number 7. Do that, get out, preset management. Look at that, 1.975. 3/10 bigger than I thought, which is fine. We've been seeing that a little bit. with the other tools. So the normal Z value, basically the top of that fixture, the top of the Aroa palette is this value. Notice I have them all kind of in the same. So from, wait. Now I'm just kind of confused. No, it works. The fact that I touched that off in plain spatial mode means that should be from here to here, I think. Anyway, point is, I think we're 3/10 over, which is fine. And if I want to, I can go in here to the tool table, tool here. I had a -6 offset. I could add 3/10 more, and the next face should be a little bit better. So let's go 0.0009 negative end. So I went from 6/10 to 9/10. Next face should be a little bit more accurate. So maybe I'm allowing myself to get distracted, but I've got the hand wheel here, and I put an indicator on the surface, and I swept it side to side to see how flat it is. And I want to show you guys. But again, maybe I'm getting distracted. So you can see there is a little bump on every step over, but we're talking, okay, I see -1/10, 0, -1/10, 0, maybe +1/10. So it's a little wavy within maybe 2/10. Which ain't half bad. Because my actual curiosity stemmed from the fact of, well, okay, if I probe here, what if I probe here? To try to get that, you know, the 1.9 number. Is it going to be a different reading here, or here, or here, or here, or here? And I probed a couple places with the probe, and I noticed like less than 1/10. So it's cool to see the manual indicator, the actual eyeball indicator, see what it does across the surface. Possibly getting slightly distracted again. However, I was talking before about different ways to do the contour here. This is a multi-axis contour in Fusion, and in the simulation the tool is actually rotating, but we have to imagine, because on the Kern the tool stays up and down straight, but the workpiece turns. So this toolpath will actually rotate the workpiece towards the tool and keep like a perfect relationship between the cutting flutes and the material. So I might go with this actually. I want to try this out. The trick is I can only do one line, so I'm going to have to pattern it all the way back like 50 lines or whatever it is to give me a similar thing to that. So one trick that I like to do in a pattern operation, where I'm patterning the operation from here to there, to there, to there, is a little feature called Keep Original. And if I uncheck that, then just like you see here, this is the first side that we did. I chose not to keep the original, so it only does side 2, 3, and 4, not redoing side 1. So I should be able to post this, and we'll be good to go. And this uses the new MultiAxis Contour, which should be pretty epic. So again, imagine instead of the tool rotating, the workpiece is rotating. And we'll see what it looks like. So here's what that looks like on this axis. A little time consuming because just the way I patterned it, but some pretty epic follow movements there. Yeah, it's certainly not the most efficient way to do it time-wise. Looks amazing though. That's really cool. Okay, you gotta see this. Check this out. Okay, so I posted one of those operations where it just does one line and then resets it. And I tested a bunch of times, so I know this works. So let's go. I even turned the coolant off for you guys. So this is tool center point something. Tool center point, I forget. Oh, it's just so cool watching it track that axis. I'm totally posting this on Instagram. It's a little jerky in the B motion because I think in Fusion it's trying to tilt the tool ever so slightly this way as it goes across. Let's do it one more time. Stunning. That's just so cool. This is just beautiful to watch. Yes, it's wasted movement. There's a lot of... It's because I'm patterning the one operation many times, so it's patterning also the retracts and the homing and the redo, basically. So it's not the most efficient, but it's really cool. I don't care what you say. I like it. I'm just going to time-lapse this. Time-lapse. Just finished. Let's see, 1 hour and 5 minutes. By far the longest cycle time so far on the Kern. Yes! So I faced the 3 sides and I did all the ribs. And I wonder if something happened with my face mill because the face started getting real craptastic. What the heck is all that garbage? Wonder if I chipped an insert or something. I noticed it here on this side and I'm like, oh, what is happening? So let me look at that insert. Alright, look at the difference between these 3 finishes. Let's start with that one. Beautiful, right? That's the first one I did. That one's getting worse. This one's way worse. And then these little ones too. What the... I bet you dimensionally it's still fine, but that finish is not that. So I pulled the tool out, I looked at it under the microscope. I'm not sure, nothing's wrong with it. It's not chipped or anything, it's not really worn out. There's a little bit of wear spots, like barely. At the corner of each flute. I wonder if it just didn't like such a light finishing pass, a 5 thou depth of cut, for such kind of a dull insert, like not a sharp ground, kind of polished aluminum style insert. Maybe I need to take a heavier finish pass. I'm just like rubbing it now. But they look almost perfect. Not 1,000,000% perfect, but close. So I'm not sure. Sure, there's some guys in the comments that can help figure out what I did wrong there to get how the finish just got worse and worse, and yet the inserts look fine-ish. Like I said, maybe the coating is barely wearing off in one of the corners, but yeah, I don't know. I'll learn. This is a test fixture. Like, I'll use it for production, but the goal is learn all my mistakes on this one and then make more. Yeah. However, I think that's done. Yes. Okay. Next step on my list. That took a very long time. Next thing on my list is to cut the mounting holes and the threaded holes and everything to mount the blade on there and the clamp. Let's do that. So I just mounted the touch probe and I measured all 4 sides just in kind of the same random location, and all 4 sides are within 5/10,000ths of an inch, 5/10, give or take, depending on where I measured, or something might be a little bit off, but considering the weird finish and consistency among the 4 sides, I'm happy right now with 5/10 range. Yeah, let's move on. Progress. So I notoriously suck at dialing in thread milling on the first try. I had to walk up on this and keep threading the hole again and again and again with the little single point thread mill. What, 5, 6, 7 times maybe? A little bit bigger, a little bit bigger, a little bit bigger. But my M6 thread gauge finally goes in perfect. Right on the low end of tightness. Goes in smooth, no wiggle. Could be a bit bigger, but that's fine. So that's good. So I made the smart choice of only threading one of the holes so I could dial it in, and then I'll go back right now and I'll thread in those other 3. If I make a mistake, I don't want to make a mistake on all 4. I'd rather limit it to just 1. So I can do that, and then I'm done. And then I can bolt a blade on there. And that is all the time we have for today, boys and girls. I'm pretty happy with my progress today. I loaded some more tools that I'll need for milling the blade, so I've done almost all the code that I need to mill the soft blade. There's just a couple more details I need to add in there. I've put in almost all the tools that I need to put in. So numbers 4 and 5 on my list I didn't actually finish and check off, but I'm really close. So first thing in the morning, I'll be able to crank those out and get them done. So I'm pretty happy with the day. It was a good productive day. The fixture looks awesome, mostly. And yeah, I'm gonna sleep good tonight. I will be back tomorrow. Later.